The Higgs particle explained why anything has mass. People call it the God particle, but the Higgs boson isn't magic. It explains why anything in the universe has mass at all. If the Higgs field didn't exist, electrons wouldn't have the masses they do, atoms wouldn't form, there would be no stars, no chemistry, no you. In the next few minutes, I'll explain what the Higgs really is, how it was discovered, and why physicists are still studying it today. Fields, not just particles. We're taught that everything is made of particles, electrons, quarks, photons. But modern physics says particles are actually ripples in fields that fill all of space. An electron is a ripple in the electron field. A photon is a ripple in the electromagnetic field. And the Higgs boson? It's a ripple in the Higgs field, a field that exists everywhere in the universe. Field arrow, ripple arrow, particle, how the Higgs gives mass. Most fields can be zero in empty space. The Higgs field is different. Even in a vacuum, it has a value. It is permanently on. When particles move through this ever-present field, they interact with it. That interaction resists motion, and that resistance is what we measure as mass. Particles that interact strongly appear heavy. Particles that interact weakly appear light. Particles that don't interact at all, like photons, remain massless. The Higgs doesn't create all mass. Most of a proton's mass comes from energy inside it, but it sets the fundamental masses of elementary particles. Discovery at CERN. In the 1960s, physicists, including Peter Higgs, predicted this mechanism. To test it, scientists at CERN built the Large Hadron Collider, a 27-kilometer ring accelerating protons to near light speed. On July 4, 2012, experiments detected a new particle at about 125 gigaelectronvolts, matching predictions for the Higgs boson. Nearly 50 years after it was proposed, it was confirmed. Why it matters. If the Higgs field were slightly different, electrons would have different masses. Chemistry could fail. Stars might never form. Tiny shifts in the Higgs field could mean a universe with no complex matter. The structure of reality depends on this invisible field. We still don't know why the Higgs has the mass it does. We don't know whether more Higgs particles exist. And we don't know whether it connects to dark matter or deeper physics. The Higgs wasn't the end of the story, it was the beginning of new questions. Subscribe for more physics explanations.